So, I'm going to be talking about the implications of our study a bit. And even though our results didn't necessarily confirm this, it did align with the outside findings that a cold environment does actually slow down neuromuscular signal transmission. And if reflexes are slower, then it is also likely that controlled movements are slower as well, because the signal has to travel to the brain and back as opposed to the spinal cord and back. So, it requires some additional processing. And this can be pretty dangerous in terms of injury because if somebody is working, let's say at a construction site or an NFL player, working in the cold, if they have to do something very quickly, in order to avoid, let's say, a dangerous situation, then these sudden movements aren't going to be as accurate or as controlled. You know what I mean? And obviously that can mean that a person can lose their balance or lose some of their coordination and then get injured. And we know that in science, these smaller building blocks help us understand sort of bigger, more complex physiological processes. And here we're looking at an excitatory movement, but this applies just as much to an inhibitory movement. If someone needs to stop doing something immediately, that additional second or fraction of a second it takes in terms of delay can be very detrimental. And a real world example that I wanted to share with you guys is of Christian McCaffrey, who is a running back for the 49ers. In 2024, I think it was December, he played a snow game where he actually got really injured. He hurt his PCL, his posterior cruciate ligament. And even though like many factors contributed to that incidence, we can apply our understanding as context for situations like these where cold environments can slow down that neuromuscular signal response, specifically the signal velocity, which increases the risk of injuries when a person is trying to make a fast movement like he did during that game. And in terms of next steps, something that we wanted to do was definitely a larger sample size. So that would kind of be the main thing, maybe around 20 people if possible, and possibly even colder temperatures as well, just to ensure that the differences in signal velocity is very clear. And maybe we could also look at more complex movements or fine movements of the fingers, or if, let's say, arms and legs have to move at the same time. That way we can learn more about several things like having several signals traveling at the same time. And maybe even we can look at performance enhancement strategies like certain warm-ups or stretches or clothing that can help or food or beverages that increase body temperature or circulation. And lastly, looking at lifestyle factors, like how much do factors such as diet or sleep contribute to the neuromuscular signaling communication.